In this video, I want to do a couple of examples of applying the chain rule to the natural exponential function e to the x. Now, we already know that one of the coolest derivatives of all time is the derivative of e to the x, and that's just e to the x. But that rule doesn't cover e to the 2x or e to the negative 17x or anything other than e to the 1x. To find the derivatives of those types of functions, we have to refer to the chain rule. Here we're asked to find the derivative of the function y equals e raised to the negative 2/3 x. And the first step to using the chain rule is to identify the inside function u and the outside function y. And we know in a lot of cases that the inside function is inside parentheses. And we can apply that same logic to e to the x. We just put parentheses around the exponent of e. And then the exponent becomes our inside function. So here, our u inside function is the exponent negative 2/3 x. And so u prime is negative 2/3. And our y function is e to the u, since u is negative 2/3 x. And so y prime is e to the u. And applying the chain rule tells us that the derivative of this function is u prime times y prime. U prime is negative 2/3. And y prime is e to the u, and substituting back in negative 2/3 x for u gives us our final derivative of negative 2/3 e raised to the negative 2/3 x. So an easy way to remember how to apply the chain rule to the natural exponential function is that the derivative will always be the original function, in this case e to the negative 2/3 x, multiplied by the derivative of the exponent, negative 2/3. Here we're asked to find the derivative of the function y equals, in the numerator, 2e to the x plus 3e to the negative x, all of that over 3. Let's separate this single fraction into two terms so that we don't have to use the quotient rule. 2e to the x plus 3e to the negative x over 3 is the same thing as 2/3 e to the x plus e to the negative x. Now we can differentiate term by term. The derivative of the first term is 2/3 e to the x. And because our second term is not just e to the x, it's e to the negative x, we have to use the chain rule. And as we discussed in the previous example, the easiest way to differentiate the natural exponential function is to write down the original function, in this case, e to the negative x, and then multiply that by the derivative of the exponent. The derivative of negative x is negative 1. And simplifying the second term in the derivative gives us 2/3 e to the x minus e to the minus x. And that's our derivative.